Hello, everyone. Thank you for joining this session today. My name is Anupam Chomal. I have been presenting at SDC Bangalore for last couple of years on various security topics. So no surprises, I'm going to present another security topic today that is about API security. So let me jump into the slides and then we can, get rolling. I'll just take a second to bring up the slides. Yes. Okay. So again, the topic, securing APIs, threats and security best practices. Let's jump into the agenda slide. I will be covering, so the flow of the presentation is pretty straightforward. I will introduce myself. I'll introduce the topic about API security, what I mean by API security, some recent security breaches. I will talk about OWASP API security top 10. And then I will talk about API security best practices. There might be occasional alarms ringing in between. That's a timer check for me so that I, keep the presentation time bound. Apologies for that. So I will just jump into the who am I slide now. I'll quickly introduce myself to you folks. I work as a software security expert with CARIAD. So what is CARIAD? CARIAD stands for Car I Am Digital. It's a software arm for Volkswagen Group. So basically, Volkswagen has multiple companies under its umbrella. It can be Audi, Porsche, Bentley, and all the likes. Now, all of these companies are offloading their software development to CARIAD. And within CARIAD, there is a security team called TS. I am part of that security team. I'm specifically into vulnerability management, and that encompasses applications in the car as well as in the cloud. So that automatically brings me to the topic of APIs, because APIs are used heavily everywhere. And that's why I chose the topic of API security for the presentation this time around. Overall, I have an experience of about 20 years, and I have worked in multiple domains like security, storage, and networking. Last around 8 years, I've been dedicatedly working in the security domain. My specific areas of interest in the security domain are around application security. So basically, end-to-end secure development lifecycle, be it during development, be it during production, or end of life. Also, I'm interested in network security as well as cloud security. So that's a brief introduction about me. Just a standard disclaimer, and let me just pull up this so that we don't miss on this. The talk represents my personal opinions. This has nothing to do with my company. So anything that I claim or I mention here is solely my own personal views. Any information that I'm sharing here is not coming from my company or from the work that I do at my company. I just wanted to bring this up front. All the data that I've collected here are from research papers and online websites. So it's not my original content. My original contribution to this presentation is bringing all the information together from my experience, from work and other things that I have learned during my career. And that's what I'm bringing you today in this presentation. I have consciously taken the effort to mention websites or papers from which I might have taken information in each of the sections. I apologize if I missed mentioning any of them. So now that these two mandatory slides are out, let's go into the introduction part. So this is a typical definition of an API. Again, the presentation is not about introduction to APIs, right? But I just wanted to get us on the same page. So I'll just introduce what APIs are, and then I will go into specific API breaches. So an API is a set of rules that defines how applications or devices can connect and communicate with each other, right? So today you have your mobile phones talking to the backend, you have servers talking to the backend. So APIs have become kind of the de facto I could say that to set up this kind of communication. We'll get into more details of where APIs are used in subsequent slides. But just to kind of sum up, there are 4 types of APIs which are generally used. You have your private APIs, you have your partner APIs, you have your public, and you have your composite APIs. Just to quickly talk about these 4 categories. So normally when you do your development, you will start with private APIs. You have your set of developers who are working together on developing some application. They create some APIs, they start making some APIs. Then that's when it's just a private API. It's used within a team, within a company, right? Then you may want to expose this to your partners because your partners are an extension of your team. You want to get information from them, share information to them. Eventually, it goes public when you want to expose it to the world altogether, right? So this is what the general categories of APIs are, and REST API is another type of API. I'm not going into that detail, but just for your reference purpose, I put the information about REST APIs. The talk is generally about API security. It is not specific about REST API security. Let me make that clear also, right? So where are APIs used? APIs are used everywhere. It is used heavily in banking. So suppose you have your customer apps that connect to the bank to do transactions, to update information and stuff. APIs have been now are being used heavily for those kind of transactions. Social media, be it Twitter, Facebook, or Google, Instagram, they all use APIs heavily today. Automotive industry. So automotive, you have your cars which communicate with the backend, autonomous driving, where cars communicate with each other and the infrastructure on the road. APIs are, how should I say, I would say de facto, but one of the widely used ways of communication between these entities, be it cloud and the car, be it car and another car, all the infrastructure. So it is heavily used in the automotive industry also. Healthcare, lots of devices communicating with the cloud backend or some storage backend, they use APIs heavily, and much more, right? So this kind of I wanted to set the stage that APIs are used across various sectors of the industry: banking, automotive, healthcare, social media, and other places. That's why it has become even more important to understand the security threats to these APIs and how we can secure our APIs much better, right? So with by setting this, let me jump into why this topic is why I chose this topic and why this topic is important. So this is something that I think was made a prediction last year, a couple of years back by Gartner, and they made this prediction to 2022. Now we are in almost, nearing the end of 2022 in a couple of months, or I would say mid of 2022. So Gartner predicted that by 2022, APIs attacks would become the most frequent attack vector, causing data breaches for entire web applications. The source I have put here. So this only goes to tell you that how critical API security has become and why we should be discussing this. Unfortunately, what I've understood my security career is, unfortunately, most companies don't start with security as, security during development phase. Security comes as an afterthought. So even with APIs development, you develop your APIs, and then you probably get the security team on board to, validate whether all the security checks have been put in. There is a concept of shift left, where you are trying to bring in security at an earlier stage of development. Trust me, doing security earlier than later makes it faster to do security. It makes it cheaper to do security, right? So there are multiple factors why we should do security earlier than later, right? Why is it relevant today? There is a push for digital transformation. Everything we are pushing online. We have so many apps for everything, even to connect to your home heater, turn it on before you're getting home, or connecting to your car and turning on the AC before you start using your car, right? There are lots of apps, there's lots of backend infrastructure, there's lots of cloud, there is lots of APIs. With the increase in digital transformation, APIs are becoming increasingly used, right? As I mentioned in the previous slide about all the sectors where APIs have been used now. Now, the risk of integrated web and the rise, of integrated web and mobile offerings requires significantly more data sharing across the products, right? So you may have a backend that is made up of multiple microservices, right? And these microservices, they don't communicate like the earlier designs that we used to have, that we had a couple of servers and you jump from one to another for some information and back. Here you have a bunch of microservices communicating with each other, sharing information, right? So, the situation becomes more complex, and even from the security perspective, things are not that straightforward, right? So the rise of integrated web and mobile-based offerings requires significantly more data sharing, and the API usage increases. So do the security cases. And these are the examples which we'll touch on later. But just to tell you that there is broken authentication, authorization, and accidental disclosure or breach of data. These are the common things that you would see normally when APIs get compromised, right? So with this, I will jump into a couple of examples of API security breaches. Again, my assumption is that you understand what are APIs and you understand why API security is critical. Also, this is not a cover-all presentation, right? In 40 minutes, it is difficult to cover all the areas. I will try my best to bring up the important, relevant topics for you, right? So let's talk about API security breaches, just to give you a feel about what kind of attacks have happened so far. These are old examples, but these are kind of the juicy examples that I wanted to share. It seems there are some statistics, and I'll just give you some ballpark numbers, but 40%, these statistics claim that 40% of organizations have had some kind of API security breaches, right? Large number of organizations claim that they don't have any security built in specifically for APIs, and so on and so forth. So just to give you a flavor about what can go wrong if you don't look at API security, let's look into some examples. So I'll start with the T-Mobile example. This happened some time back actually, but basically you had a web interface, and in the web interface, in the URL query, once you're authenticated, you would see your mobile number in the URL interface. Now, authentication and authorization are two different things. You get authenticated, and then the backend application did not check for authorization. What do you mean by that? So what the attackers did was, once you were authenticated, once you had logged in the URL, they changed the mobile number, right? These things stand out. If you have something unique, like a name or an ID or a phone number, that's a place where an attack can happen. So the attackers changed the mobile number, and then they could see all the information of some other user that they were not supposed to view. So they were not authorized. They were authenticated. They were authorized to view their data, but they were not authorized to view other users' data. However, because of this bug, they were actually able to use the other users' data, right? About another trivia about this attack, someone even made a video of the attack and published it online for others to see and try. And it was online for a while. It was only later that T-Mobile actually realized that they have suffered this breach. Again, the fact that I want to highlight, you are authenticated, but you're not authorized. So that's a broken. I'll come to that part later. I'll skip it for now. Then another thing that happened here was they did not have sufficient, how should I say, monitoring in place. If they had the monitoring, they would realize that an attack is ongoing, right? So that's another thing that will come up in the OWASP top 10, and in my tips also, that the T-Mobile folks did not even know that they are undergoing an attack. I think it lasted for 2 weeks before they actually realized, and they patched the whole thing. Then the Facebook data breach. So here also almost similar thing. there was a view as feature in Facebook earlier, where people could see their own profile, right? But what they started doing was they switched one of the unique parameter, the name or something. I exactly don't remember what they switched, but just like the phone number, assume they switched that unique parameter, and by switching that, they could see some other user's data, right? This vulnerability actually generated an access token that had permission of the Facebook mobile app, not for the viewer, but for the other Facebook user whose name they have switched. And then using that, they could actually get access to the access token and do whatever the other user could do. So definitely they were able to use the other user, view the other user's data, but they also had access that the other user was supposed to have. So this was another Facebook security breach. And then I want to bring up another security breach of Uber. And this is again along the same lines. What really happened here was, I have not put much details in the slide, but I'll explain to you because this is an interesting hack that happened. So when a new Uber driver joins the platform through a referral, they were taken to some API host for registration. Now the registration triggers an API call to the API endpoint. The API receives the user ID parameter from the client and returns the details about the user, right? So API has received the user ID parameter, it returns the detail about the user, but this information is all the information about the user. This information is populated the consent screen on the client side. So if I am a new driver, I have come through a referral link. I will go to this. I click this. I go to the API host. The API host will return all my information to me in the consent screen. As a part of the legitimate flow, this seems okay, and the user should see only their own user ID information. However, there were two possibilities here. And again, I was going to introduce this later, but I think I'll bring it up now. There is something called a BOLA, broken object level authorization, right? The program here did not validate that the client who sent the request has access to the user represented by the user ID parameter, right? So the client is authenticated. The client application is passing a user ID to the server, but the client is changing that user ID to somebody else, right? And the server is not authenticating that this particular user ID actually belongs to the person who kind of authenticated first time around. The second was the excessive data exposure, right? So the API responded by giving the entire user information in the consent screen, right? All user details that it was not supposed to. It gave out excessive data, right? So if you there is a thing that you can follow in API security. Only store data that you need to, then automatically the possibility of sharing extra data is ruled out, right? Also, share only data that you need to share, right? Here, what Uber was doing is it was sharing all the data of the user at the time of registration in the consent screen, and the attacker changed that user ID in the parameter to actually get all the information of some other user that it was not supposed to see, right? So these are some typical examples of API security breaches. Every day these breaches are happening. You would find all this security breach information on multiple websites. This was just to set the tone about what are the possible or some juicy security breaches that have happened so far in this area, right? So again, we started by looking at the basic of APIs, why we feel API security is important. And now we have seen some API security breaches, right? So let's move to the next part where we look at the OWASP API security top 10. Now, again, OWASP creates these top 10 lists for multiple topics, and they have created this good top 10 list for API security. So let's jump into that list, and let's start with the first one. The broken object level authentication. This is what we started with. You have seen this in all the examples. You have also seen one where there was insufficient logging or monitoring, but and excessive data exposure. But let's again go to this one. Here, the program didn't validate that the client who was sending the request has access to the user represented by the user ID parameter, right? The client could access data of other users by changing the user ID. So the client got authenticated, and after authentication, the client changed the user ID parameter, right, to get some other user's information. Now, what typically attackers do is they try to find this unique field, like in the case of T-Mobile, it was a mobile number, right? Or it can be some name or some other unique number. And if you have a unique number, what is the first thing that you try to do? As an attacker, as an API security tester, you might want to enumerate all possible numbers. If you're enumerating all possible numbers, then what should ideally the server do? It should do rate limiting. It should avoid any kind of such recursive checks. That is another thing that is in the OWASP top 10. I'll touch on the later part. So broken object level authorization, as I've just covered, and we have seen in other examples. So this is the first of the OWASP top 10. I will move to the next one. Broken user authentication, right? So what is broken user authentications? APIs with broken user authentication allow malicious hackers to assume the identity of legitimate users to access sensitive information, right? So you may, so it is kind of similar to the first one, but what here is happening is that you are authenticated for yourself, but not for the other user. It's like you're getting a token of the other user, and using that token, you can do operations that you're not supposed to do, right? So again, hackers can assume the identity of legitimate users and access their sensitive information by this broken user authentication, right? That is the second of the OWASP top 10. Again, I'm not going into the details of this because it's unfortunately not possible to cover going into detail in the 40 minutes that I have. My idea is to tell you why this is important, examples of breaches, what does the OWASP top 10 say, and some recommendations from my side on how to improve the security, right? So let's move to the third point, and that is excessive data exposure. We have already seen this multiple times, but let me just reiterate. When a user requests access to a resource, the API returns the full data object stored in the application. As in the case of Uber, when the attacker kind of send the registration, Uber actually returned all the information about the attacker in the consent screen, right? So you're sending out excessive information than is required, right? The client application is actually, the model is, and this is the base model of API, is that you have clients, the clients request for a resource, the server returns a large object set, and then the client filters, right? Filters information as per necessary for that particular transaction. So if you're using a mobile client, the mobile client is supposed to filter out the data that is required, remove the unnecessary data, and only show the data that is relevant for that particular transaction, right? Unfortunately, developers often mistake the implementing API as generic data sources, and they send out all information for most of the transactions, and the attackers calling the API directly to access the data, not via the client, but directly, right? Get this entire information, right? So an attacker would use some kind of mechanism. There are lots of tools where you can actually do these API calls, and the developers, they are sharing the entire data set. The attacker gets the entire data set. Ideally, the application, the mobile application, for example, calling that particular API should be filtering and giving only limited information. But since here the attacker is calling directly, all that information is available to the attacker, right? Again, only collect and share the data that we need. That is another point that we should follow here. Lack of resources and rate limiting. This is a kind of a no-brainer, actually. As I gave an example during a couple of minutes back, what the attacker would want to do is enumerate. It would go through that entire possible set of user IDs. So suppose sometimes what developers do is that they create a unique ID for each user, and the unique ID can be some numeric ID, say 1050. When the attacker sees something like this, the attacker will try to enumerate all possible IDs. So the attacker can start with 1, 2, 3, and so on and so forth, and look at all the space and see if some kind of data is generated and the response from the server, right? And now, if you're doing some kind of rate limiting, you would automatically realize that this user is doing too much of transactions in a limited set of time, and it will block that particular user, or at least deny access for a while. This also protects you from the possibility of denial of service, DOS, right? Typical cases, this is not built in. And another thing that an attacker could do, he or she can actually create a request to upload or modify large files, or make multiple requests through that same authentication. That can lead to the server being overwhelmed, resources running out of resources, running out of memory, eventually leading to denial of service, right? So lack of resources basically means that you would run out of your server resources. And if you're not doing rate limiting, then attackers can have this possibility of trying all possible combinations to pull out data from the server, right? I'll move to the next one, broken function level authorization. So what is broken function level authorization? Again, the same thing. The API mistakenly relies on the client to use user level or admin level APIs appropriately, right? So your APIs will have something only for users, something only for admins. Now, typically in the URL, an attacker, he or she, they will try to find out the hidden admin APIs, right, and methods, and would try to invoke them directly. So you might have a URL, someserver.com/user/something. What if I change that user to admin? If I change that to admin, is it possible to access admin APIs directly? That's what attackers normally try to do. Now, some administrative functions might be exposed, and non-privileged users can access these functions without authorization if they try this out, right? So again, we have to avoid such situations. And to do this, what we should do is we should not rely on the client to enforce admin access, right? The client may try to change the URL, may try to access something that they are not supposed to. So at least the server should not rely on the client. Deny all access by default, right? Only give access when it is necessary and should be given depending on the transaction. Only allow operations to users belong to appropriate group or roles. Again, this is important. Sometimes, many a times in many of these attacks, you would realize that this is completely missed out, right? A user, sometimes an attacker goes ahead and she deletes all the objects in the database, right? That would not have been possible if appropriate group or role privileges were checked out, right? And lastly, I feel you should properly design and test authorization, right? That's the core. This will happen if security is built in from scratch since day one and does not come as an afterthought. Changing these APIs would be really difficult later on, right? So let's move to the next point, mass assignment, right? So again, it falls around the same lines. Client data is accepted and stored without proper filtering, right? What basically an attacker might do is that after a transaction, the server is supposed to take only, so the client is providing 4 fields of data. The server is supposed to take that 4 field of data and insert into the database. However, the client might send along with the 4 another 10 bits of information, right? These were probably not meant to be updated. For example, admin role, right? And because it has not been checked, the data that the client is sending is not filtered or checked, it might be blindly transformed into an object and stored in the database. Now, an attacker can try to guess object properties or provide additional object properties in their request, even that they were not supposed to, right? So this is another possibility that can happen, and that's what the masked assignment talks about. Next is security misconfiguration. This is again a pretty straightforward thing. Using HTTP and not enforcing HTTPS, right? Data leakage. You are giving out too much of information that you're not supposed to. data corruption through unsanitized inputs. So you're getting input, you're not checking the inputs, and an attacker might send out a bigger data set than was supposed to. That may lead to data corruption. And also data leakage through error messages. So you give out error messages and you give out information about the user in the error message. One of the attacks, I can't remember offhand, but in one of the attacks in the error message, you got information about the user, and using that information, the attacker actually went ahead and created a legit string to actually pass on to the server, right? So again, this is about security misconfiguration injection. This is again the normal injection. You have because attackers can supply untrusted data as part of a command or a query. It can trigger the application to execute them to gain access to sensitive data for the hacker, right? You should sanitize the data, check the data, don't trust any data that is provided by the user, right? Typical injection attacks are like privilege that can lead to privilege elevation, denial of service. And the common ones that I was talking about is SQL injection, command injection, cross-site scripting, etc. Right? So this is a standard item that is there in other OWASP top 10s. And this is something that has to be followed. Again, sanitizing the input that is coming from the user. Right? Last one, oh no, this is the ninth one actually, improper asset management. What is improper asset management? There is always a need to have backward compatibility in all applications. So what the developers do is they release a new API, but they also keep the old one running, right? Now attackers commonly target such old versions to take advantage of outdated security checks, right? So there would be multiple APIs running, some public, private, some developer APIs that is exposing much more than they're supposed to, right? So that's what attackers normally try to find out. Is there an older version running, right? This is the actual category of improper asset management. Lastly, this I have covered multiple times before, insufficient logging and monitoring. Again, just to summarize, an attack might happen over a long period of time. An attacker might do a reconnaissance. After reconnaissance, maybe try to get some information. There'll be lots of failures, input validation failure, failed authentication checks, application errors that might come out because of invalid access. All this should be logged. If you log this and you use sufficient tools, Zeem tools, you know, that look at these logs and point out if there's some anomalous thing happening, then you can avoid such attacks, right? In the absence of such alerts, attackers can stay undetected for extended period of time. That happened like in the case of T-Mobile, enabling them to actually exploit the system fully, right? So this is something that applies to all security areas. You should have sufficient logging and monitoring, right? So this is my summary of most common causes of API attacks. And I would just give that, say, for example, insufficient input validation, like I mentioned. And this is what I have summarized from the top 10 OWASP and what I feel is critical for API security, right? One of the things is you don't validate the input that is coming from the user. And this applies everywhere. It applies in your normal C programming, normal web application development, normal programming with any other language. You should sanitize, don't trust the input that is coming from the user. If you're not doing the input validation, you are inviting trouble. Missing rate limiting. Even when you do server hardening or you do Linux hardening, there are cases where if you do multiple, there are rules that if you have multiple unsuccessful login attempts, the account gets locked, or you can log in after some period of time. Similarly, when you have these APIs, you should have a rate limit built in. If you're not building a rate limiting, you are giving the attacker an opportunity to try multiple times with multiple combinations, right? And if you would have done sufficient logging, which is coming down later in the list, then you would have caught such attempts earlier. Data error leaks sensitive information, right? As in the case of Uber, you are leaking data and your errors are also leaking data, and they are probably leaking sensitive information. The example which I gave where the error message actually had that unique user field that the attackers then used to enumerate all possible users, right? Broken object level authorization, we have touched this earlier. it's also called insecure direct object level reference. They both are the same. So if you see these two terms, they are referring to the same thing, right? Application uses user provided input to access objects directly. So in case of T-Mobile, the mobile number, the attacker used some other person's mobile number, right? The application has used user provided data instead of checking whether that user is authorized to get information for that mobile number, right? Predictable identifiers lead to enumeration of resources. Like I said, numbers. If you are putting a unique number 1 to 10 or some enumeration, then it becomes easier for the attacker to try enumeration. See how this links. That you are putting a predictable identifier, some kind of number, and you're not doing rate limiting. So an attacker can try multiple number combinations, and since there's no rate limiting in place, it can enumerate through an entire data set and pull out all the information that is there in your database, right? Last point, there is authentication check, but you forgot to do authorization check. Yes. So you have authenticated the user, but you have not checked whether the user is authorized to access that particular data set. And insufficient logging, I think I'll skip this part. Again, I have this tendency to try to cram in as much information as possible in my presentations. API gateways are something really interesting. I just wanted to point out that other than these, API gateways are also turning out to be an important source of security as far as this ecosystem is concerned. So what is an API gateway? Is kind of a reverse proxy. It sits between the API server and the clients, and it aggregates and routes requests coming from the clients to the appropriate backend service, right? And it returns the result accordingly. Now, fine. This is some kind of load balancing that is happening. Why should you have API gateways? It can provide with rate limiting, it can provide with access control, it can provide with encryption, right? Again, in one of the points I mentioned, no HTTP, only HTTPS. In fact, strict HTTP, if it can be enforced, it's better. Now, this one device is doing all of this for you. It is making sure you are doing rate limiting, access control, and encryption. That's why API gateways are kind of a good thing to have. Of course, they are costly. Of course, API, this last point, API gateway helps in security, but also needs to be secured. So again, that's one point of failure, plus can lead to massive breaches. But as I said, it can be very good in terms of the security implementation when it can do rate limiting, access control, and encryption and other things for you. Even logging. Sorry, I missed out on logging. So I have a slide that just explains the API gateway. So API gateway sitting between the client and the services and doing logging for you, right? So best practices, just to summarize, authenticate. Always authenticate the user. And sorry, I missed out, put authentication and authorization checks, right? These should be built into your design. Secure communication. Always use HTTPS, TLS, of course, at the bottom. If you're not using secure communication, then it's all the other security that you're building in will beat the purpose. An attacker would sniff some data, change some data, things like that. Implement sufficient logging, because no matter how much security you built in, some point of time you're going to be breached. If you'd be lucky if you're breached and you come to know that you're breached. If there's an attack ongoing, like in the case of some recent big attacks where the attackers were within the organization, within the setup for an extended period of time till they were detected, right? That is the worst case scenario for any organization. So logging and I would say sufficient monitoring of the logs to see if there's something anomalous happening is really critical. API gateway, I put API gateway into the mix because API gateway can be that one place where you do all of this. You do your logging, you do your authentication, you do your encryption, So API gateway can be something that you should consider implementing for your API infrastructure and API firewalls, right? So these are some of the best practices that I wanted to generally highlight that you can use to secure your APIs. And yeah, that's it. So again, just to summarize, API security is really critical today. APIs are used extensively everywhere. It makes the application very easy, and it makes data exchange effortless. However, with great powers come great responsibility. So your API using APIs, they open up a wide field of information or a surface area for the attacker to attack, right? And since this is kind of an upcoming topic, the security or the breaches are not that well known. So it is even more important that you take care of these nuances of security or possible breaches even better. Learn from the breaches that others have suffered. Ask questions that if a data is stolen, how can the attacker use the data? If the attacker can use the data, do you really need to store that data? Right? Those are the kind of questions that you should be asking, and build API security at the start of design initial phase rather than bringing it as an afterthought. Right? The OWASP top 10 is to give you a feel about the possible attack vector, so to speak, but it's not an all-encompassing, all-covering. Right? You should also look at your infrastructure. You should look at your public APIs, private APIs, what you're exposing, what you're storing, right? But that is a good starting point. The best practices which I've given are is what I feel that you should do, but these are not necessarily sufficient to provide security. They are a good starting step. So again, thank you for attending my topic, my presentation. Please take a note to rate this session. Your feedback is important because it helps deciding what should be brought up, what the users are actually wanting to listen, and it also helps us, the presenters, improve in terms of content and quality of presentation. So please rate this session after the presentation. Thank you for attending this session. And I hope this really helps you in your API security effort. All the best. And yeah, you can always reach out to me on my email ID, which I've included at the start of the presentation, if you're interested in this topic and want to discuss about me. Thank you.